Hello, how are we doing? It's Mike again, and this is a follow-up to the last video that we just discussed. In the last video, we discussed singular points, and then we moved along to determine how to find the rate of change or the first derivative of a parametric curve at any given point. We used points that were consistent with that of a xy plane, but we had to convert the points from the regular xy plane into the parametric point t. So for the x value, y value 1, 1, we found that the parametric parameter t equals to 1. When x and y both equal to 1, we found that t equals to negative 1. When x equals to 1 and y equals to negative 1. So if you need to, go back and review the last video before we go and discuss the last topic of this section. Well, not the last topic of the section, but the majority of this section is how to find our second derivative. So I'll tell you a very common mistake that is made. A very common mistake that is made. And let me just be able to press my... There we go. So many people, as we defined x as a function of t and y as a function of t, we know that dy over dx is equal to dy over dt, all divided by dx over dt. So this we know to be true because if we just divide these, we'll have dy over dt times dt over dx. The dt's cancel, and we get dy over dx. I feel really comfortable about how to determine our first derivative, but I will tell you a very common situation occurs. Where people often make the mistake when they're looking for d squared y over dx squared. I will tell you this is not equal to d squared y over dt squared divided by d squared x over dt squared. Be very careful because I cannot tell you how many times I have seen this error occur. So be very careful. This is not true. This is not true. So let's go ahead now and determine the second derivative. Let's show us how we find the second derivative. So if we're looking for d squared y over dx squared, this will be equal to dy prime over dx. dy prime over dx. dy prime is dy prime over dt, and this is all over dx all over dt. dy prime over dt over dx divided by that dt. So be very careful about this. Means take what. So basically, we're going to find the derivative of y over with respect to t. So we're taking the derivative. I'm sorry, I wrote this wrong. So we're taking the derivative of dy dt, and we're dividing it by dx dt. So this is going to be the formula for d squared y over dx squared when you're given a parameter. So going back to our original, we had x equals to t squared and y equals to t cubed. dx over dt is equal to 2t. dy over dt is equal to 3t squared. 3t squared. 3t squared. So the question happens on how do we find this portion right here. So in reality, when I found dy over dx, this gave me 3t squared over 2t, which is 3t all over 2. This portion is an interesting concept. This portion is an interesting concept. So be very careful about this. I wrote this dy. I should have taken this with respect. I apologize. This should be dy dx up here. So this should be dy dx. So we're going to take the derivative with respect to t of dy dx, and this will equal to 3t all over 2 prime all divided by dx dt. Dx dt is going to be our first value of 2t. So this will just equal to a value of 3/4, but, oops, 3/4 over t, sorry, 3/4 over t, yeah, because this gives me 3/2, this gives me 2t, so we get 3/4 t. So this, in fact, will be equal to d squared y over dx squared. So just as a summary, d squared y over dx squared will be equal to the derivative of the first derivative as a parameter all over dx dt. So be very cognizant that you do not make this error. Make sure to keep this down and really keep this close to that it's going to be the derivative of our first derivative with respect to t, and then divided by dx dt.